Hello guys, welcome back to Maison African Motives, still working on A-level mathematics. In this case, we are going to continue on our trigonometry. We talked about this a long time, but we are on the part of proof of identity. So make sure that you watch other videos on just basic introduction of trigonometry for A-level, so that we can be able to prove these together. So the first part that we have is that to prove an identity is simply to simplify a certain identity. All right. We have a simplification that we had before, whereby maybe you are given to simplify, maybe this is sine 2 theta over the cos of theta like this. The question was just simplify. So you are just given to simplify a certain question, all right? Sine 2 theta is equal to cos theta over cos theta. So from your identities, remember from your double angle, sine of 2 theta can be expressed. This is sine of 2 theta, which we can be written, some they can write as 2x, whatever way that you are going to write this, which is going to give us the 2 sine of x, the cosine of x. So meaning to say, if this is the sine of 2 theta, this is going to be 2 sine of theta, the cosine of theta over the cos of theta like this, whereby we can cancel the cos and the cos together. We remain with 2 sine of theta. Okay. The question was on simplifying this fraction, but because of proving now, they are simply taking that part that you were simplifying before. Now they are asking you to prove that this is going to give us this. Or they can simplify the answer in another format that they want you to represent your final answer as. That is the proof part. So if you are given to prove an identity, it's still same thing that we talked about before, simplifying of trig identities or ratios that you'll be given. Okay, which is going to be in major use of our identities, talking of the Pythagorean identities, cos squared x plus the sine squared of x, which you know this is equal to 1, and the 1 plus the tan squared of x, which is equivalent to sec squared x. Also, we have got cot squared x plus 1, which is equivalent to cosec squared x. We are supposed to get in use of these. And also remember, we also referred or talked about the sine of theta over the cos of theta, which gives us tan of theta. If it is cos of theta over sine of theta, this is going to give us the cot of theta. And that is simply the same as 1 over tan of theta. Cot theta is same as 1 over tan, same as cos over sine. Also, we referred to the 1 of sine theta, which is equivalent to cosec of theta, the 1 over cos of theta, which is equivalent to sec of theta. So also these, they are going to be in use as you are simplifying together with your double angle, your double angles, your compound angles. So you are supposed to change whatever that is not in simplest form or that is not simplified into any of the simplest, especially working with these ratios, that is to interchange any of these, especially if you are given sec, change it to a cos, a cosec to a sine, a cot to a something that you are used mostly to. That is how you can actually prove much better. Okay, so I'm going to pose some questions that we are going to work on so that we can try to prove these identities. So we are asked to prove the following identities: that the tan of theta plus cot theta. All right, we have got cot theta is equivalent to 2 over sine 2 theta. So we are asked to prove this. Okay, so on the proof part, one, you shall have a condition that you are going to prove from the left-hand side to show that it is equal to the right-hand side, which gives us a direct solution of what is exactly on the right-hand side. Or there can be a condition where you are going to prove from the left-hand side you obtain a certain answer. That is not exactly the same as the one that you have on the right-hand side. Then you prove again from the right-hand side. You're supposed to obtain the same answer as the one that you got when you were proving from the left-hand side. So there can be two ways of doing that. So in this case, let's see which one are we going to have in this case. Okay, so let's just save this as our first question to prove. All right, so we are going to refer, in this case, I'm just going to take them this part where we are given two terms. At least we can reduce it to a single term. Than to work from a single term to expand that single term is going to be difficult for us, but we can even work from there. All right, so taking the left-hand side, we are given this as the tan of theta plus the cot of theta in this case. So knowing that from the ratios that we talk, remember we say that tan is same as sine over cos. So we can write this as the sine of theta over the cos of theta plus cot, remember, is cos over sine. So this is cos of theta over the sine of theta. So that is what you're going to have in this case. So we are now back to our addition of normal fractions where we need to determine or to find the LCM of the given denominators, that is cos theta and sine theta. So we are going to have the sine of theta, cos of theta, or you can write it as cos theta, sine theta, okay? So how can we simplify? You can divide sine theta, cos theta, divide by cos theta. Cos and cos will cancel. We remain with sine. So it's sine times sine, which is going to give us sine squared theta plus. We do the same here. Sine theta, cos theta, divide by sine theta, sine, and sine will cancel. We remain with cos. So it's cos times cos, which is cos squared theta. But remembering that we talked about that cos squared plus sine squared is going to give us a 1 from our Pythagorean identities. Cos squared x plus sine squared x is equal to 1. So meaning to say, in place of cos squared, this one, in place of sine squared plus cos squared, we can replace with 1. This is the same thing as cos squared plus sine squared. So this is going to give us 1 over the sine of theta, cos of theta. Okay, so now let's get back to the simplification now to say, on our final answer, we have what we have. Okay, let's check what we have on our final. On our final answer, we are given this as 2 over sine 2 theta, which means you have to check, because you could have simplified this way, because we know that 1 over sine theta is cosec. So you could have written this as cosec theta, 1 over sine over cos theta, which is sec theta. But this is not what we are given on our final answer. It means they didn't divide by 1. So what was the considering? What happened? How are we going to simplify? Because we are not given what we are used to. So that is what I was saying. You have to check with the question that you're given. So in this case, we have got the sine of 2 theta, which we know that it was taken from this part. We talked about this sine of 2 theta. Remember, I wrote this identity before, where I said the sine of 2 theta is same as the 2 sine of theta cos of what? Cos of theta. So in this case, we are not having 2 sine theta cos. Take note, guys, we are not having this. But we know that this sine 2 theta is equal to 2 sine theta cos. But here we are having sine theta, which is we are having this part alone, this one. There is no 2. This 2 is not there. So what are we going to do so that we can obtain 2 sine theta cos theta? We are going to multiply both the numerator and denominator by 2, which is 2 over 2. 2 over 2 is simply 1. We haven't changed anything, because 2 divided by 2 is 1. So 1 times that we are still having the same thing. But only we need to achieve this part. So which means if we are to multiply by 2, this is going to give us 2 over, that is 1 times 2, which is 2 over sine theta cos times 2. This is going to give us 2 sine theta cos theta. So do not divide these two, and because if you divide, you are going to refer back to this part. So you leave it as it is. What we need is this part now. 2 sine theta cos theta, which you said 2 sine theta cos theta is equal to what? To sine 2 theta. So this is the part that is going to give us sine 2 theta. So therefore, we are going to have 2 over 2 sine theta, 2 sine theta cos theta, which is a sine of 2 theta, which is the one that we were given on the right-hand side. So this is exactly the solution that we need this case, which is 2 over sine 2 theta. So you have to be very careful, which you check with your solution, the answer that you are given. You have to also cross-check back again to see the answer that I'm given. And with this simplification, where I'm going, am I going to obtain this given solution? So that is the purpose of referring back to the answer that you are given on the solution. Okay, I have another question again on proving these identities. Let's see what we are given in this case, our question 2, where we are given again to prove the identity that is 1 plus the sine of x everything over the cos of x plus the cos of x everything over 1 plus the sine of x is equivalent to 2 over cos x. So the question is to prove. So how can we prove this one, guys? How can we prove this identity that we are given? All right. So if we are to check, just like the previous case, we are going to check, take one of the sides that is the most complicated. So we reduce that side into a single term. So we are going to work with the left-hand side. We are given. So in this case, we are back again fractions. We are dealing with fractions. So meaning to say from the left-hand side, we are supposed to combine everything together in this case, finding the LCM just like the previous part. So we're asking ourselves, what is the LCM of the cos theta and 1 plus sine theta? That is cos theta into 1 plus sine theta. So you can have this as cos theta, cos x, sorry, into 1 plus the sine of x. So we can divide back the denominator, the LCM, which is our lowest common multiple or the lowest common denominator, divide by cos x. So cos and cos cancels, we remain with 1 plus sine x. So this is going to be the 1 plus sine x that we got times the 1 plus sine x in the numerator. So it's going to be 1 plus sine x plus, we've got a plus here. We divide again our LCM to the denominator 1 plus sine x. 1 plus sine x will cancel. We remain with cos x and cos x. So this is going to be cos x times cos x. All right. So knowing that if we are to multiply, this is a times a, we're going to obtain a squared. So it means if you are to multiply the brackets, which are the same, 1 plus sine x, 1 plus sine x, this is going to give us 1 plus sine x squared, or you can expand the given bracket, or this is just 1 plus what? Sine x squared. The same thing, cos and cos, this is going to give us cos squared x. So we're going to have cos squared x, everything over our LCM. In this case, we can expand by cos, or we can just leave it for now because we do not know what's going to happen later on. So let's just leave it for now. This is 1 plus sine of x. All right, like this. This is where we are. If we are to check here, we have a bracket that we're supposed to expand 1 plus sine x squared, which we can refer back to the expansion of a plus b squared. All right. If we are given a plus b squared, any bracket to the power of 2 is given 2 terms. This is going to give us a squared plus 2ab plus b squared. When it is a negative, it is going to be a minus b squared, which is equal to a squared minus 2ab plus b. You're supposed to know these identities or expansions when you're expanding brackets. This can lessen your calculations, okay? Instead of expanding those 2 brackets, we can simply apply this concept. Okay, so in this case, our a is this a1, our b is sine. So that means in this case, we are going to have a squared, which is 1 squared, and 1 squared is 1, plus 2ab, that is 2 times a, our a, which is 1, times our b, which is sine x. So it's 2 times 1 times sine x, which is 2 sine x. So we're going to obtain 2 sine x plus the last term, which is b squared, Our b is sine, so it's sine x squared, which is sine squared x. Or like I said, you can expand those brackets properly using that expansion of brackets from your O level is still fine. But let's just try to advance. We are now into A level, where we can at least apply some other typical calculations. Okay, plus, remember, we still have the cos squared on our calculation. So we're going to have cos squared x, everything over, in this case, the cosine of x into 1 plus the sine of x. Never be tempted to cancel at this stage, because in the numerator, these are terms that we are having are like an expression. So you can't cancel anything. Don't be tempted to cancel cos squared and cos x, because this is an expression. So we can simplify further. How can we simplify? We are now having this part here, the sine of x squared and the cos squared x, this part that we talked about before, that this whole part gives us a 1. So we are going to obtain a 1 from this part, meaning to say we can add this 1 to 1, because this whole part is now represented by 1. So it's 1 plus 1, which is 2. So you're going to have 2 plus 2 sine x, everything over our denominator, which is the cosine of x, into 1 plus the sine of x. There's something that is happening there in the numerator. You can see that something is common there. 2 is common, so you can factor out the 2. That is 2 divided by 2, which is 1. So this is going to give us a 1. Then it's 2 sine x divided by 2. 2 and 2 cancels. We remain with plus sine x, everything over the cos of x into 1 plus the sine of x. So this, we can see that these two are actually the same. We can cancel brackets which are the same, provided it's under multiplication. These brackets can be cancelled, which means we are going to remain with the 2 in the numerator. That is on the top here. That is our numerator. We are remaining with 2. In the denominator, we are remaining with cos x, which is exactly what we're given on our identity on the right-hand side, 2 over the cos of x. So this is the answer that we're exactly given. So that is exactly equal to the right-hand side in this case. So that is how we can prove identities in this case. So it's very, very important, very, very important when you are proving identities to apply basic concept of the knowledge of fractions, and also the knowledge of other trigonometrical identities, the Pythagorean identities. Is it the double angle? Is it the compound angle? Is very, very important if you are proving other identities, because you can use another identity to prove another identity. Okay, let's check another question in this case that I'm having. Again, is on proving identities. All right, so let's check this question. That will be our question 3 in this case. All right, we are given to prove the cosec of theta minus, in this case, we have got the sine of theta, everything over 1 plus cos theta. And the question is to prove that this is equivalent to the cot of theta. Okay. Again, we can see that, okay, the best side to work with is the left-hand side. So we can work from the left-hand side. So from the left-hand side, what are we having? We are now having those cosec. Where is this cosec coming from? Where are we having the cosec from? Remember, cosec is from 1 over sine of theta. So this is 1 over sine of theta minus sine and cos. They are already in simplest form. There's nothing that we can do. We just have to rewrite as they are. So that is the sine of theta over 1 plus the cosine of theta. So having this, we can prove that this is going to give us cot of theta by subtracting. This time we are going to subtract. That is the same way like what we applied in the previous case, finding the LCM of the given denominators, which is going to be the sine of theta into 1 plus the cosine of theta. So let's divide our LCM to sine theta, sine cancels. So that is going to be 1 times what we are obtaining, which is 1 plus the cos of theta minus 1 plus cos theta and 1 plus cos theta, they cancel. So you remain with sine and sine. So that's 1 sine times sine which is sine squared. So you're going to obtain sine squared theta. All right, expanding the brackets by 1 times 1, this is 1 times cos theta, this is cos theta, minus sine squared theta, everything over. We can expand our brackets, but for now we do not know what's going to happen, just like the previous part. So it's best for you to just leave the denominator as it is, the LCM as it is. So this is going to be sine theta into 1 plus the cos of theta, like this. Okay. The question is, how can we simplify further from this stage? If we are to check in the numerator, that is where we are having the most complicated. We are having cos, we are now having sine. So we can't even combine or factorize, just like what we have in the denominator. To write that sine into 1 plus, it's like a factorized manner, because just like 2 into x plus y. If we expand, this is 2x plus 2y. So which means this is in a factorized manner. But this one is difficult for us to factorize, because here we've got cos, you have got sine. So what can we do? We can focus on this sine squared. How can we change this into a cos? Because we have a relationship from the Pythagorean identity that states that the cos squared of theta plus the sine squared of theta gives us a 1. So in this case, we want to substitute or to remove this sine squared theta with the equivalent value for sine squared theta from this identity that we are given. So we can make sine squared theta the subject. That means sine squared theta is equal to transpose cos squared to the other side of the equation. This is going to be a negative. So it's 1 minus cos squared theta. So it means in place of sine squared theta, we can substitute with 1 minus cos squared theta. So what does it mean? We can substitute back into this part here. So that means we are going to have 1 plus cos of theta, which is this part that we had before, minus, we substitute now the answer that is equivalent to sine squared theta, but in terms of cos, which is 1 minus cos, which is an expression. There are two terms. So open a bracket to simplify this part. So this is 1 minus cos squared theta in a bracket, so that the negative is going to affect every term inside of the bracket. So that's sine theta over into 1 plus cos theta in this case. Okay, expand the brackets. The bracket that you are given in the numerator, we've got 1 plus the cosine of theta. Then we can expand. This is same as -1. So it's -1 times 1, which is -1. This is -1 and a negative cos. So it's going to be positive cos squared theta. Everything over our LCM as it is. So this is sine theta into 1 plus the cos of theta. All right, we are almost there. If we are to check now, we can see that in the numerator there is something that is happening between 1 and 1. These two can actually cancel 1 minus 1, that's a 0, meaning to say we are going to remain with the cos theta and cos squared theta plus cos. So cos, we can factor out cos, because just like our factors, cos is now common here. So we can factor out the cos of theta, meaning to say cos theta and cos theta, that's a 1. Cos squared theta divide by cos theta, which is going to be cos theta, because we are having 2 of them here. So we remain with 1. Everything over the sine of theta into the bracket of 1 plus cos theta. Just like the previous question, we can see that, okay, the 1 plus cos theta in the numerator is the same as the 1 plus cos theta in the denominator. So these two, they can cancel, meaning to say we remain with cos over sine. So this is going to be the cos of theta over the sine of theta. So that is over the sine of theta, of which we know that cos over sine is equal to cot theta from the identities that we, from our ratios that we mentioned before. Cot, it's cos over sine. If it is sine over cos, it's tan. So this is what we are given. Is it the same as what we are given on the right hand side? This is exactly the same. That is cot theta in this case. So this is our simplification. That is how we can prove any identity that you're given. It's a matter of also just having a foresight. What am I trying to say? Just to have that foresight to say, if you are given a question, you must even know how the answer, how the steps that you're going to take to the answer. Some stages that are not necessary, don't include those stages in your proving of these identities. All right. So let's have our last question. In this case, on proving of identities. Okay, so we've got the last question in this case, where we are given the cosine of theta, everything over the tan of theta into 1 minus sine theta is equivalent to 1 plus 1 over sine theta. All right, so this is what we are asked to prove in this case. Okay, so in this case, this one is a little bit complicated in such a way that you can even want to work from the right-hand side because there are two terms there. Okay, we can actually work from the right-hand side, but there's something that I want us to see here. On the left-hand side, we have got a lot of expansions that we can make. We have got the tan and the expansion of brackets, so we can take that advantage, but even working from the right-hand side can actually work. All right, so let's see, working from the left-hand side, what are we going to obtain in this case? All right, so this is left-hand side. Okay, let me indicate the marker. So that is from the left-hand side, we are given the cos of theta over the tan into 1 minus sine theta. So tan, remember that it is equivalent to sine over cos. So we are going to have the sine of the tan of theta as the sine of theta over the cos of theta, like this, into 1 minus sine theta. So this is what we have for now. All right. If you are to check here, there's something that is happening. These terms, they're outside of the brackets. They do not need any involvement of brackets or any involvement of other term to be simplified. I'm referring to this term, cos theta, and this one, the sine theta over cos theta, the one that we are dividing. We can divide these terms separately. So we can actually divide, that is cos theta. When divided to sine over cos, we are going to multiply. So it is going to be cos over sine. Remember, the moment you multiply, you invert the second fraction. So it is going to be cos over sine. So that is same as over 1. So cos times cos, which is cos squared theta, 1 times sine theta, which is sine theta. So meaning to say, if we are to simplify this, we are going to have cos squared over sine theta. So we can rewrite this as cos squared in the numerator, then the sine of theta in the denominator. So it's going to be sine theta into this bracket of 1 minus sine theta, like this. Okay, so this is where we are at this stage. Okay, what is happening? What can we do in this case? If we are to check here, we have 1 minus sine theta, we have sine theta. It's only from the numerator where we are having cos. What if we can get rid of this cos? Because we saw that last time we got rid of sine squared. So which means we can also get rid of cos squared from the same identity that we had, our Pythagorean of cos squared theta plus sine squared theta, which is equal to 1. We can actually make the cos to be the subject. We can transpose cos to be the subject, meaning to say the cos squared of theta is equal to 1 minus sine squared theta. So that means in place of this whole part of cos squared theta, I can substitute 1 minus sine squared theta. So this can be written as 1 minus sine squared theta, everything over our LCM, where we've got 1 over sine theta, or we've got sine theta into 1 minus sine theta, like this. If you are to check now, our expression or the trig that we have, the trig ratio, is all on sine. We've got sine, we've got sine, we've got sine. So which means we can we have some hope that we are going somewhere, because the answer was also in terms of sign. I wanted to check. This is how you prove. You prove also checking on your answer. Your answer, which is the right hand side, is also in terms of sine theta. So that we have that hope that we are actually in the right direction. Okay. If you are to check here, there's something that is most important that most of us, we do not realize, which is the difference of two squares, which is on 1 minus sine squared. From which concept? The a squared minus b squared, it is equal to a minus b into a plus b. That is the factorization of difference of two squares, where these two terms are perfect squares, which is 1 can be written as a perfect square because 1 is same as 1 squared. So we have got 1 squared and we have got the sine of theta squared. So this is a squared minus b squared. So if we obtain a minus b, where our a is 1, our b is sine theta, this is going to be 1 minus the sine of theta, that is a minus b. A plus b, that is 1 plus the sine of theta. So that is how you can factorize our difference of two squares, or we can just apply that concept from our O-level mathematics. So this is 1 minus sine theta like this. Okay, so as you can see, we are having the same magic just like the previous part, where these two can cancel because they are the same. So this is going to give us, in the numerator, we remain with 1 plus the sine of theta over the sine of theta. If it was on a normal consideration or on a normal simplification, truly we were going to leave our answer at this stage. This was the correct answer. But because this is a proof where we are supposed to read the mind of the examiner to say, wow, what was the mind of the examiner on this question? The answer that we are given is not exactly the answer that we are given. Let's check our answer. Our answer is given as 1 plus 1 over a, 1 over sine theta, 1 plus 1 over sine theta. What happened in this case? They simply divided each term by sine theta, because we understand that terms can be separated from a single fraction of a plus c over b. I can separate this as a over b plus c over b, as long each term is divided by b. So this is the concept that we can do. We can separate 1 plus sine theta separated by sine theta. This is going to be 1 over the sine of theta, just like a over b, plus the sine of theta over the sine of theta. So this is going to be the sine of theta over the sine of theta, which cancels sine theta, that's a 1. So this is going to give us 1 plus 1 over sine of theta, which is exactly the answer that we're given on the right-hand side. Whether you know that 1 over sine theta gives you cosec of theta, you do not apply that. You answer the question that is to prove. So to prove, you neglect all your mind aside. You read the mind of the examiner. So most of us, this topic becomes a challenge because we have our own simplification that we are used to. This is not about that. This is about the mind of the examiner, because the same question that I'm answering, someone can answer this in another way, as long we are along the mind of the examiner. Okay, so that's what we had, guys, on proof of identities. We shall move on, or we shall have another class where we shall have also past exam papers, revisions on proof of identities, application of our compound angles, our double angle identities, and so forth. But for now, that's it from Meson African Motives. Till we meet again.